If there's one thing I love about a good graphical user interface, it's a big, juicy button. Hi everybody, welcome to Lazy Devs Academy. Welcome to this little instructor pod on how to make buttons in Picotron. I think a lot of people are struggling to get into Picotron. It seems daunting and seems complicated. There is a mouse, we can click on things. You know, it seems like it's a whole different beast than Pico 8, and I completely understand that. I think one easy way to get into the fray to start working with Picotron is to focus on what you see on the screen and how you interact with stuff. I want to talk about the graphical user interface, and that is actually something that is not very well documented in the README of Picotron right now. The way I understand it, it's still something that's work in progress, it's still being worked on, therefore it's still not documented because things might change. But what about us developers? We want to get started, we want to get stuff on the screen, we want to start clicking on things. Now today I want to get started with something very easy, with something very basic. I want to make a button. How do I make a button in Picotron that you can click on? And that simple goal will ease us into the GUI system of Picotron. Let's get started. Alright, so I have a fresh new Picotron file open here. I will save it right away. I'm going to save it as but. Just to be clear, this is a 12-year-old zone. Everything will be, by default, abbreviated as but. Just can't be bothered to write those two extra letters. All right, so just like with Pico 8, we're going to start with a little init function, and then we're going to do a little update function, right? The same thing as Pico 8. It's the same stuff. And then we're gonna do a little draw function, right? These are all things we are familiar with in Pico 8. Now if we save this and if we run this, we get a black screen. Woo, great. So how do we make a button appear here? Well, first of all, let me clarify that you don't need to use the GUI system that is built into Picotron. In fact, in Pico 8, I would find myself quite often making GUI stuff, making buttons and menus and so forth. And I would just do them manually. There was no system built in. I would just draw them on the screen and make them interactable with the mouse or the keys, right? So for example, in the draw function, we could do rect, and then we can do like, let's see, I figured out a good position for the button. That would be something like this. And this is a good width, and this is good height. We're going to do, this is our rect, rounded rectangle. We had that, that was recently introduced in Pico 8. It was here for a longer time in Picotron. It's possible just rounded rectangles. So this is the X position, Y position, with height, and this is the roundness of the rectangle, right? And then we're going to say, let's make it a very dark button here, right? And then that's it. And then we're drawing our button. Hey, this is a button here, right? Now we can do a CLS in here, something like this, yay. And then like this, we can print something inside the button using the print statement. Now, obviously, it is not interactable with a mouse. So let's make it interactable. But first, before we make it interactable, let's define, like, because we might want to move the button around, right? So let's go BX, BY. Let's define the position of the button, right? Something like this. We define it like BX is assigned to 210. BY is assigned to 80, easy, right? And we're then gonna plug those into our drawing function, right? So the drawing function will take those values from those variables. Yes, this is working. So now let's do like a function that checks for interaction with those buttons. I want to hover with the mouse over the button, right? I want the button to light up when I hover with the mouse on it. In Pico 8, this was a bit complicated. You had to dig into like the stat function that would return some kind of like system variables, and one of those variables would be the mouse X and Y position. In Picotron, the mouse is a way more integral part of the system. So there's a function that allows us to get the status of the mouse, and that is the function mouse. And the function mouse returns 3 values. It returns the X, Y position, and the mouse button. It might return more values, I'm not sure. But I care about these 3 things, right? So let us just do like a MX, MY, MB. So 3 variables, and we assign them the return values of the function mouse. So X position of the mouse, Y position of the mouse, and a variable that encodes all of the buttons that have been pressed. And then I prepared like an if statement like here. This is just regular collision detection. We dealt with this in the basic Schmuck tutorial. If you don't know how collision detection works, I'm gonna refer back to that episode. Yeah, we're just checking the position of the mouse against the left and right position of the button and the width and the height of the button and so forth. And if that's true, then that means the mouse position has collided with the button. And then we can maybe, for example, maybe there is a variable, right? bHov, that indicates if the button is hovered upon, right? And then we're going to set it to true. Then also means that by default, it's going to be false. And then down here, when we're drawing the button, we're gonna we can do a ternary, but just like for clarity's sakes, we're gonna go if bHov then and then we're gonna go local bcolor, and usually the bcolor is gonna be 5. But if we are hovering, then bcolor is gonna be 7, and then the colors of the button and like the frame around the button and the text is going to be set to that color, whatever color is set, things are set to. And now we can, when we hover over this, but it doesn't get unhovered. So that's why we need to, in the update function, we need to set it to false, so it gets unhovered. And look at this, right? Now we're hovering over the button. That's great. So there's like interaction happening here. And then inside this if statement, we could also like check for the mouse button. If that's true, if that's 1, then, and then we could trigger something. For example, let's say we have a debug text that is usually nothing. And we're going to draw that debug text to the screen. It's going to be red. And then if we click the button, then we're going to go debug equals click, right? So this is how we're going to see if this worked. It worked. So now we click on the button and we set a variable to click. That was complicated, right? That was a lot of code. Look at how much code it is for just a single button. Crazy, right? And then you can imagine if there's like 20 buttons in the game, imagine how much code there would be. Now, to be fair, if you have a lot of buttons, you might figure out some kind of like universal functions, like a function that checks the collision detection, a function that draws like a default button. And in fact, this is kind of what the GUI system of Picotron is. It's just like somebody, Zep in this case, going through all the effort of creating such a system with all these little functions that allow you to make GUIs very easily without having to repeat yourself, and packaging it as a bunch of functions and objects. Now, to be clear, there's nothing wrong about making a GUI like this, making it manually like this. If this is more understandable to you, if this is something that feels safer or more familiar, then go ahead and make a GUI like this. It will take a little bit more time, but also you will feel like you have more control over what's going on. That's nice. But obviously this is not why you're watching this video, so let us look at how the GUI system works. Now, before we jump into the GUI system, let me first show you, because there's no documentation. The only thing that you can really learn about the GUI system is actually looking at the code, and it's hidden here. If you open up your drive, you go into the system, and then you will find the lib folder, and in the lib folder you will find the GUI Lua. And then if you open this is just like there's some text in here, some thoughts that Zep has written down for himself. And then you can just scroll through this, and it spells out, how the GUI system works. This is literally the GUI system that we're going to take advantage of. Now, this is not the most easiest code to understand, because there's a whole bunch of stuff happening in here. Oakley dokley. So let us delete all of this stuff. We're just gonna reset things. We're gonna keep the debug around. We're gonna delete all of the stuff, and let's make a GUI. Now there's a function to create a GUI object, and that is create_GUI. It is built into Picotron. It's something that's fundamental, and that will create an object that is a graphical user interface. Now, that interface can be one button, it can be 100 buttons, it can be different things, not just buttons, but other things, right? It can be all sorts of things, and you can have multiple of those. You can have as many as you want. For example, you might want to have a menu with multiple pages, and then you might want to maybe set up something like each page of the menu will have its own GUI object, and you can like swap objects in and out to show a different arrangement of buttons and lists and so forth. It's up to you. view. In this case, we're just going to use one GUI object, but later on I will show you some methods to organize your GUI and how that works. Right, so create GUI returns our GUI object, and you can call it whatever you want. I'm going to call it my GUI, and that will be the create GUI. That will be our little GUI. Now, after we create our GUI, we also need to update it, so it needs to react to events, for example, like the mouse button. We have to animate this, right? So there's an update happening with the GUI, and there's also, we have to actually draw it to the screen. We have to draw it. So that works like this. So my GUI, in update function, we're going to go my GUI colon. That's weird. I'm going to explain in a second. Update underscore all. And then in the draw function, it's very similar, but here we're going to go up. We're going to go my GUI draw all. And just to clarify, if you have multiple GUI objects for some reason, then you have to update and draw each object separately. So that's why it makes sense to only have one. So you don't have to update and draw multiple objects, right? But it might be a good idea to maybe swap an object in and out through the same variable. Now, this is the part where I have to explain you what the colon means and why there's a function attached to an object. If this stuff is very clear to you, you can skip to the next section. There's going to be chapters in this video. But if you don't know what this means, here's what it means. So first of all, this is a method. The update all part, that is a method. It's a very fancy name for just a function that is stored in an object. If you don't know what an object is, well, the basic shmup tutorial has you covered. We have a whole episode just dealing and explaining what objects are. I'm going to post the number of the episode down there. So maybe you watch this first and then come back to here so you can understand what is happening. Now, again, a method is a function that is stored in a property of an object. And it's this whole object-oriented programming kind of thing. The real object-oriented programming goes a lot deeper into this, where you have like public and private and so forth, and you have create classes of objects beforehand and so forth. None of this is important for us right now. All that we need to know is that update all is a function that is attached to our my GUI object. It's stored kind of like in the object, so to speak, and each GUI object will have this update all function associated with it. And it's kind of nice because if you don't have any GUI, then you don't have to deal with this function at all. You don't even have access to the function. And also, if you're updating the GUI, it only makes sense in combination with an object. So it doesn't really make sense for the function to exist if there's no GUI. Now, the colon is something that kind of like threw me off a little bit, and that's kind of like unusual, but it's also not very complicated at all. It's if you have properties, object properties, for example, you might have a property like .x, right? Or my GUI .y or something like this, properties, right? So the colon is kind of like the same thing, but we like to use it with situations where we have a function saved in those properties, like in our case. So what it actually does is this. It calls a function in a property, and then it supplies a reference to the object that the property is saved in as the first parameter. That's all it does. And in fact, instead of this first part, you could also just write it like this. You could use the dot way of writing things. That would be also fine, as long as you supply again, a reference to the object that the method is saved in, you're fine. You can also write it out like this. The only thing that the colon does, it makes it a little bit more compact, and I will prefer using the colon in this case, and it will come up in other situations later down the line as well, just so we're clear on that. And of course, we're using the same thing as here. So again, instead of my GUI draw all, you can also write my GUI dot draw all, and the first parameter becomes my GUI. If you actually supply some parameters, by the way, like if the call would be something like this, then the equivalent of that would be something like this. So you kind of like inject the reference, the my GUI reference, as a first parameter, and then all other parameters come afterwards. All of this is just kind of like faffing about. All that you really need to know is that there's a magical spell that you need to write. You need to write this to update the GUI, and you need to write this to draw it. Now, if you run this, there's nothing happening right now, and that is because this GUI is empty. There's nothing attached to it. So now we need to attach elements to the GUI. We need to create buttons, for example. That's what we want to do in this video. We want to create buttons. So this is how you create a button. So you go my GUI colon again, attach button. For some reason, it doesn't turn green, but it doesn't matter. It doesn't matter. It works. And then inside as a parameter of attach button, you need to actually attach some information about what kind of button you want to create. And that information is stored in, you have to create an object for that, right? You could do it like inline and start defining your stuff in here. But just for clarity's sake, because there's going to be a whole bunch of parameters, I'm going to create a little local myBut. And then I will put parameters for our little object, for our little button in here. And then we're going to just attach myBut using the function. So for each button needs a position. It needs to be located somewhere on the screen. So we're going to use the same numbers that we had previously that we figured out were good numbers. And that maybe we need to have a label. That is what is written on the button. myBut. And that is it. So this is now a little object that we created, right? And then we put that object into this function here, and that attaches this object to the GUI. Now the object that we created, this myBut object, now becomes the button. It gets all sorts of other stuff attached to it by the attach button function. It gets like modified, morphed into the button. So actually we could continue. It might be a good idea to save the button in an array so you can continue interacting with it. But otherwise it gets just dumped into the myGUI as well. And then it gets updated here and it gets drawn here along with all of the other potential future buttons that we're going to drop into the GUI. So here's what it looks like. Hey! And look, it's interactable. If I hover over it, it lights up. The colors that are taken here are taken from the default settings in the theme of Picotron, and you can even click on it, and it actually does something. It animates when you click on it, and you can see how the mouse cursor even changes to a little hand. Isn't that nice? Okay, so let us maybe look at maybe some ways of customizing this. So there's actually three properties that you can add to the button that will customize the way it will look. One is called BG_color. That's background color. And well, you have to supply it a number. We're gonna take apart the number in a second. The other one that we need to define, we can define, we don't have to go, but we can, is go FG_col. And then we also can define border. BG_col, let's go 0, something like this, right? So these three properties that are optional, if you're not define them, you know, Picotron will figure out something out for you. But if you want to know exactly what the button's supposed to look like, you can define those three colors. So if you run this, you see now the button is all blue. Ooh, isn't that cool? But also if you hover over it, it disappears. Why is that happening? Well, so again, BG_color is just the fill color of the button, the background color. That's just black, that's fine. Foreground color is actually the color of the text inside the button. And then border is the color of the border of the button, obviously. Now the reason why it's turning black is because actually there is a bit of a trick going on. Actually, what we're defining here with this number is actually two colors. The color that the button has when it's not interacted with, and the color that the button has when the mouse hovers over it. But accidentally, the way we defined it right now is it made it so that the color of the button turns black. The button turns entirely black when we hover with the mouse over it. That is because this number is supposed to be hexadecimal. Ugh! I hate hexadecimal, but we have to get through it. Okay, so let's write this out as hexadecimal. We can go something like 0705, right? We're going to do the same thing for the other button. So let me write this down, and you can see now the button is gray, and if you hover over it, it turns white. Why is that? Well, so you can see there's actually two numbers written in here in those 4 digits. We have this number, this first number, that is the color of the button when you hover with the mouse over it. And the second 2 digits is the color of the button when nothing happens, when the mouse is not hovering over it, right? And as you can see, like, for example, if you want the button to be red, red is the color 8, right? If you go here, you see there is number 8 up here, right? So if you change the 7 to an 8, the button will turn red when you mouse over it, right? And of course, this also applies to the background as well. So for right now, the background is black, so it looks like this. But if you want the background to be blue, deep blue, right? Like where's the blue color? I think it's this one, right? If we want to have this deep blue color when we hover over it, then we have to set this digit to 1, and then we get a deep blue color here. Ooh. And obviously it's hexadecimal, so once you get into over 10, then you go A, B, C, D, and so forth. So I think in this case, if you want to go back to the blue color that we had previously, would it be B? It would be B, right? Let's see. Is it B? No. C? Yes. So this would be the color if you wanted to have the button to be all blue. All right, so these are some things you can play around with to make the button look the way you want it to look. Now, let's talk about how we can make the button do things. Right now, the button doesn't do things. How does that work? Well, like with the GUI that we have, where there's a function attached to an object, right? Like update all function. We can also attach functions to this button, so the button does something, right? And in our case, there's a whole bunch of pre-built functions that get executed when we do something with the button. And obviously, there is a function called click, and then we can put a function in this click. We can attach a function. There's multiple ways of doing this. I will just create a whole new function for this. And then we're going to call it my click, right? And then we're going to just we're going to put this function, we're going to assign this function to this property, to the property click. And that means that when the GUI does its thing, when it gets updated, you know, and when the GUI detects that somebody clicked on the button, then the GUI will run my click, or it will run click, which is assigned to my click, which is this thing here. So whatever happens, the stuff that happens when you click on the button is going to be defined here in the my click function. And for this, we're going to go debug has click. There's a problem. I forgot a comma here. Bam, has click. It worked. It worked. Our button does now something when you click on it. Isn't it neat? All right, so now we have buttons. We can click on the buttons. Everything is sweet and juicy and good. And now a couple of pitfalls to watch out for. When you assign a function to a property, you want to actually save the function, not actually execute the function, then you can't have open and close parentheses. That's something that's very easy to get wrong, right? Because you just, every time you deal with a function, you open and close parentheses after this. Not in this case. Don't do open and close parentheses, okay? Also, in order to make things a bit more compact, because now you have to like create a whole new function for every button, that can get a little bit like, you might have to create a lot of functions for this, and that might take a lot of space. So there's a way to make things a little bit more simpler, right? You can define a function right here inside the object. You don't have to create a function outside of it, right? And this looks like this. You go click equals function end, right? So we can just do it like here, right? And then we can do something like has also click, right? And then when we run this, we run this function. So this code gets kind of like executed, like defined within our button definition. That's neat. And of course, if you're really hardcore about it, and if you really want to be like, really just like, I don't care, just make me a button, whatever, then you can do this entire definition in line. And in fact, that's something that sometimes I see people do, and it's fine, but also incredibly unreadable. But hey, if you just quick and dirty prototype, right? You don't want to spell out a lot of stuff, then you can do all the definition inside the my but here, and that looks a little bit like this. So you just put the entire object in here, and you can do it all in one line. And look, it's working, right? The button's still working, it's still working, right? And it's just a single line. The entire button was created with a single line of code. And that's nice. That can be very efficient and quick and compact. Now, for the purpose of our tutorial, I think this is a little bit confusing, so let me return to the old ways. There we go. One thing I wanted to also mention is that you see that the button is scaled automatically to match the width of the label. Something you can still do, that's a bit of a hack, is you can still modify the width of the button after it was created. So if you're not happy with the width that Picotron decides that the button should have, you can still change it afterwards. You can just go my but width equals, say, 40 afterwards. 80. And there you go. Now the button is way wider. This can be fun if you want to have like a nice layout where all the buttons are, the same size and so forth. This can be a good way to do. And this is also a good reason why you want to maybe, keep around, a reference to your button objects so you can still modify them after the fact. Now, is clicking the only thing that you can do with the buttons? Of course not. There's a whole bunch of things that you can do with the buttons. Let me show you some stuff. So here is a bit of a cheat sheet, of all of the functions that you can also define here in your button object. You obviously have click, but you can also check for a double click. Drag and drop functions are possible. They're a bit more complicated. I will maybe treat them a different video. Release means if the mouse button was released. Tap is when you clicked and released without moving the mouse, so just like a very quick click, so to speak. And the mouse wheel is when you're scrolling the mouse over while hovering over the button. Now you might be asking things like, hey, can I figure out if somebody clicked with the left or right mouse button? You absolutely can do this. But you need to get some more information about what kind of thing happened to the button, what kind of event happened to the button. This thing here, this click, we could call this an event. An event happened to our button, and as a result, a function gets called. And that function actually receives some information about the event that happened. We just need to get it and need to decode it a little bit. So the way this works is, let me restore my old definition here like this, right? So now we're using this old function, my click here. And that function actually receives two parameters. One of the parameters is self. That is a reference to just the button that you just clicked on, which is very useful in many cases. I will maybe show you some examples. But also you get a message object. And that message object has a whole bunch of information about what kind of click exactly it was that just happened. And we can just draw, for example, we can debug something. We can go MSG, that is our message. It has the property MB, that is the mouse button MSG, there we go. That was the mouse button we just clicked. So MB, if you just print it into our debug, if you click, see 1 means the left mouse button, 2 means the right mouse button, and 3, it's not the third mouse button, it's left and right together. So if you do that, you get 3. And then the middle mouse button is 4. It is actually a bit field of buttons. And the first bit is the first button, the second bit is the second button, and if you have 1 and 1 together in binary, you get 3. And then the third mouse button is the third bit. But yeah, if you just want to check for the right mouse button, just checking it for if it equals 2 is fine enough, I think. So yeah, this msg.mb gets you which mouse button was used. Funny enough, when I was using this, I had some problems getting the MB from the release event. Like if you release the mouse button, it wouldn't actually record which mouse button was released, which is a little bit annoying. But just letting you know. Oh, by the way, I think it also has the hover. Let's see if hover works. It works. So hover is also a thing that you can also have here. And again, you can also have the parameters in an inline function as well, just to show you how this looks like. You go function, self, msg. You can all use different names. I'm just using them because that makes sense to me. So you could call it strawberry and raspberry, I don't know, whatever you want. Let's make this do something else also, and then change to click. So now you see if you click this, it says also 1 and also 2. So this is how an inline defined function that has no name, how that can also receive parameters. And yeah, if you just want to know what else you can have in a message, so different message properties that you can check for is something like MSG. You can go MX, the position of the mouse. You can go MY. You can get MB for the mouse button that we just did. You can also check for wheel X and wheel Y. So that's the mouse wheel, and it supports for sideways scrolling with mouses, which I guess some Macs do. But most of the time you will be checking for wheel Y, which is how much, I guess, the mouse wheel has scrolled if you want to do any mouse wheel interactions. Okay, so let me show you a little bit how we can have multiple buttons, because I maybe want to show you a little bit how buttons interact with each other. So for example, if we want to create 5 buttons, we're going to go for I equals 1 to 5, do. We're going to spread them vertically depending on the I, and that's going to be it. And then we have multiple buttons. So it's so easy, right? Of course, they all called the same. So let me just add the number of the buttons. So button 1, 2, 3, 4. I have 5 buttons. But of course, they all have their own function that does the same thing. So we might want to maybe exchange the functions here. Something you can also do, you can take advantage of the self property, right? And you can do something like if self dot label, for example, we're going to check what's written on the button, right? Equals something like this, right? We check for the name of the button, or the label of the button, and if it's the first button, we have slightly different behavior, right? So now the first button says first button, but the other buttons just print out the mouse button that we just pressed. But also you can define your own properties, right? Because this is not restrictive. You can have your own the properties. So let's call it like, you know, my number, right? And then we're gonna save the I here, right? In my number, in the my number property. We can also check for that property. If my number equals 1, then, right? And now it works the same way, but instead of checking for the label, which might not be reliable, maybe the caption changes sometimes, you can also invent new properties of the button and make the button respond to those new properties. It's fine. Now, one of the reasons why I created multiple buttons is I wanted to also show you what happens when GUI elements starts overlapping. So now we overdid things and now they're overlapping a little bit. So you can see there's an ordering of the buttons. The button number 5, gets drawn at the very last, and so it's drawn on top of the other buttons. But maybe you want to change the ordering of the buttons, right? Well, you can do that too, and that is there's functions for this. Bring to front and push to back, and they do exactly what you think they do. And something we can do is, so when we click on a button, I want to push the button to the back, right? So let's go self push to the back in the function that is being executed when you click on a button. And then when I click here on a 5, it gets pushed to the back now. On a 4, stuff gets pushed to the back. And this is how we can reorder or define the order in which things are drawn on the screen. Before we get into the grand finale, where we create our own juicy buttons, I wanted to first talk about 2 important properties that are very useful to know. One is that you can hide a button. And you can do that by going self.hidden equals true. And if something is hidden, then it's exactly what it sounds like. It's just not there anymore. So now we can make a button disappear. Ooh, now they're all gone. Ooh, and you can no longer click on them anymore. They're just gone, right? So that's a very nice and easy way to just hide an element. The other property that is very useful to know is you can have GUI elements like buttons that are just not reacting to anything, like not to the mouse anymore. This is useful when you have like some situations like here where GUI elements are overlapping each other, and you might want to have one GUI element that's maybe some kind of decoration, some kind of star on top of the button, right? That you don't want to be clickable, right? It's just a little visual flourish, right? In this case, you can set it to ghost. So we're going to do something like, we're going to set the button number 5. We're going to set that button ghost equals true. So now button number 5 is no longer clickable. As you can see, if I hover over button number 5, actually the button number 4 gets highlighted, the one underneath, because button number 5 is just ignored for the purpose of mouse interactions. Neat. Can be very useful if you have very complex layered interfaces with lots of elements. Now, let us go to the grand finale. This is nice and good, but what if I want to have a completely different button? This is a nice button and all, don't get me wrong. But what if I want to have a button that, I don't know, maybe is square, doesn't have those rounded corners. I want to have square buttons, or maybe I want to have a drop shadow, or maybe I want to have an icon on the button. Like, obviously, that's not possible. This is just a default button, right? Or maybe I want to have a button that changes states. When you click on a button, it's highlighted. When you click on it again, it's like a toggle button, like a toggle switch. How do I make my own stuff? my own GUI element? Well, it's very similar to creating a button. It's just you have to do a little bit of the work yourself. So let me do a bit of clear up. So here's where we create a button, right? Here's how we create a button, attach button. Well, we can also do something else. We can also go my GUI, just attach. And that's it, right? We can just do a generic GUI element and attach that to our GUI. And the problem is now we have to do some more definitions about how that GUI element works. And we're just going to do that. So the same thing as with a button, the GUI element is defined by an object. And we're going to do that object. And we're going to do, the same thing that we had before. There is an X position, obviously. There's also a Y position, like so. And then there's also, that's very important, that's something that we didn't have to do in the button, but we have to do for custom GUI elements or for custom buttons. We have to specify a width, and we have to specify a height. It has to be specified. If it's not there, you're not going to see anything. And that is it. So if you run this, we see nothing. Well, because we created the element and it's being drawn, it's just like we do nothing when we're drawing it. So we do have to specify something, how the element is being drawn. And it works as you would expect. There's a function called draw, and that function gets called whenever the UI wants to draw this GUI element. And we have to assign it a function the way we assigned a function to the event of clicking, right? So let's call it my but draw. So we're going to assign draw this function. And again, like previously, I'm not going to do it now, but as I did it previously, you can also define the function right here in an object. So you don't have to create a separate function for this. I just, for clarity's sake, I'm not going to do it in its own function. And let's do like a rect fill. And we're just going to fill a huge rectangle of 400, 340, whatever, and a 560, and it's going to be all red. So we should see a gigantic rectangle on the screen. I overpromised the size of the rectangle. What happened? Well, there is some things you need to know about how the GUI system works. First of all, you notice that how we're drawing the rectangle starting at 0, 0. But our rectangle here is in the middle of the screen. That is because when the GUI draws its GUI elements, it does a camera, the function camera, which means it changes the coordinate system so that 0, 0 becomes the top left corner of that GUI element. So whatever we defined here, 210 and 100, whatever we defined as the position of our GUI element or our custom button, that becomes 0, 0. So you don't have to deal with the position of the button when you're drawing the button. That's something that the GUI takes care of, so to speak. And the second thing, and that is why we have to define the width and height, is that it also does a clip. It also does a clip function. So whatever drawing you do is restrained to the width and height of the GUI element. So even if you want to draw a huge rectangle on the screen when we are drawing that GUI element, that rectangle gets clipped into the actual size of our button that we actually drawing. If you want to have this button to be bigger, we need to make the width and height of that little canvas of our custom button, we need to make that bigger, right? So if you want to have really big, then you have to make that button really big. But obviously this will also affect, mouse interactions and other stuff as well. All right, back to normalcy, back to a normal button, something like this, right? Okay, good. So let us just recreate the default button, but with our own code, right? So if you want to recreate the default button, that would be something like rrect, right? And then 0, 0, because it's the top left corner of the button. And then we have to take the width and height of the button. And because we have the self property, right? We have the self parameter. That's actually the button that is being drawn. We're going to go self with the and self height. And then the rounding is 2 and 8 is the color. So now we have a nice red button. Ooh! And we're drawing it all by ourselves. We can decide whatever we want to do about this button. If you want to have this button now all square, then we're just going to turn off the rounding basically. Or if we can make it really round, we can make it all like pill shaped, like if it was Mac OS or something. And if you want to print something in here, obviously we can do this as well. let's go 5, 2, something like this, and we also make it red, so you can see now it's here. You can position it however we want. You can make it go further down. We can make it go a little bit to the left. You know, it's all up to you. You can decide what the buttons will look like. And if you want to make a button that does not look like the standard button, you can do so too. So now it becomes all big and so forth. You can really go in there and make your GUI elements look exactly the way you want, but you just want to make sure that you're not getting outside of the boundaries of your button, right? That's something that the system will not allow you to do. What is happening here? There we go. All right, it's not the most beautiful button in the world, but it's here and I'm happy for it. And of course, what I said before works now too. So this will still, you can still click on that button. It's still a clickable button. It's fine, right? You can still click on it and stuff will still happen, right? Right, I clicked it and it says now, yes, click. Perfect, perfect. All right, I want to show you a couple of tricks that I think are useful that I stole from the default button behavior because it's kind of really smart. As I said, there's a hover function that you can use. So you could create, if you want to have a button that lights up when you hover with a mouse over it, you could use the hover function to do that. And you can also change maybe the appearance of the button here in the click function and so forth. But actually, the default buttons are actually using some cool tricks of doing all of that stuff inside the draw function. I want to show you this because this is kind of neat. And in fact, you can actually look it up, what the default draw function of the button looks like. You can, if you look for attach button in the GUI Lua that we opened before, you can see this is what is actually happening when you create a button. And it just creates a GUI element, and this is the draw function of the default button. This is what it looks like. And it has some really nice tricks. This is something that you can, for example, this is something that checks if the mouse cursor is currently over this button. So we can go if this is MSG, this is the message of the event that is happening. This is the draw event, right? So it kind of tells you what's happening to the button currently as it's being drawn. And if it has a property has pointer, which means if the pointer is currently over this button. So if MSG has pointer, then, so if the mouse cursor is currently over the button, we can maybe change color. Let's go local, bcall, let's set it to usually to 8. But if the mouse button is over it, we're gonna set it to 7, right? And then when we're drawing the button, we're drawing it with that color. So now when I hover over the button with my mouse, it lights out automatically. Isn't that neat? Isn't that nice? What about clicking? And again, we have some information about this. This is what clicking does. This is the clicking part here. Let's just copy that part out because this is also very neat. So this basically says if the mouse button is greater than 1, so if any button was pressed and the mouse cursor is currently hovering over the button, then in this case, a variable gets counted up. So let's create that variable, local, let's call it GUI, and let's set it to 0 usually. But when the mouse button is over it and it's being clicked, then we're going to set it to 1. And then we're going to change the position of the text, the Y position. We're going to add BY to that. So now if I click, you can see the text is moved by 1 pixel downwards. So it's looked as if we pressed on the button. Very simple effect, but it's very effective at making the button look all nice and interactable. Obviously, you can set up your own system that can be a lot more elaborate, and you can already see how, for example, we could create a toggle button here, right? So for example, let's say toggled equals false. And then when we click on this, we're going to go self.toggled equals not self.toggled, right? So we're going to flip the whatever it was. If it was false, it will turn into true. If it was true, it will turn into false. And then I'm going to go if self.toggled, then else. So we're going to draw the button differently when it's toggled. We're going to do a solid fill when it's toggled. And we're going to print the text in black. Something like this, rect fill when it's toggled and the text is going to be black. So look, now when we click, bam, it gets all toggled. And when we click again, it gets untoggled. Isn't that neat? Isn't that super nice? So this blows the door wide open. You can create a whole bunch of custom interactable elements on the screen. Custom buttons, they look as the way you want them to look. They can have icons, they can have even animations. They can also behave the way you want them to. They will interact to mouse interactions however you want. Now, one last thing, and that is all about, I want to show you a little bit organization stuff. This is something I still haven't wrapped my head completely around this, but this GUI system is very flexible, and I'm going to show you a little bit how you can use this to organize things. Something that quite often happens in GUIs is that GUIs change. You click on a thing and then maybe a panel opens up and it has a whole bunch of buttons. And then you click on something and you minimize it and it disappears again. When you click on a unit in a RTS, a whole bunch of menus of different things that you can do with this unit pops up. Things come in and out of the view. And also sometimes you want to move things around. You want to maybe change the layout a little bit. You want to move those buttons to the left so you have more space because you want to add something to the GUI. So a very important feature of a good GUI system is the ability to move things around, to manage them, to cluster them together to things that belong together. Well, you can do this with the system as well. Let me show you how. So you can see how we attached a button directly to the GUI, right? Well, you can attach things to other things in the GUI, like it becomes a whole tree. So you can create GUI elements that are not themselves buttons, they are just containers for other GUI elements. Let me first create a bunch of my buttons. All right, something like this. We did this before. I just do a loop from 1 to 3. Here's the positioning. I'm going to use the eye of the loop to spread them apart a little bit. I'm going to create 3 of those buttons. They're all clickable now, and we can toggle them, and you can see each one of them has its own state. Ooh, that's nice. But now you can imagine what happens if I want to move those buttons. What happens if I want to make all those buttons disappear because they're kind of like associated with a unit on the screen, and I want to like click on things and then they should disappear, right? Then I would have to loop through all those buttons and set hidden property to each button separately. It would make sense, maybe because they belong together, to cluster them together into a single GUI element of a panel of buttons, so to speak. And we can do that by creating our own custom container element, so to speak. So we're going to go my container equals, and then it's a whole GUI element, so we can set it an X position. We can set it a Y position. Now we have to set width and height. And there is a trick here that I like, which is there is a property that is also kind of like width and height, but it's slightly different and useful in the case of a container. That is width underscore rel. That means a relative width. So that means whatever this container gets attached to, it becomes as big as the thing that it gets attached to. In our case, we want to attach the container to our entire GUI, and that's just as big as the screen. And so we can set the width height to 1.0. So it's exactly as big as the screen. If it was 0.5, it would be half as big as the screen. You know? At least that's what I think it works. I'm not exactly sure. And yeah, height works exactly the same way. So now we have created an empty container that does nothing. It just exists and it has a size. And now what we can do is when we attach something to our GUI, or first of all, let's attach that container to our GUI. My GUI attach. So we created this invisible container now to our GUI. And now we can attach the buttons. Instead of attaching them to the GUI, we're going to attach them to the container. And you can see, oh, now they're off to the side. Why are off to the side? Well, because the container already has an X and Y position. And the buttons now, the position of the buttons is now relative to the X and Y position of the container. So now the buttons can be at 0. And now when we move the container, we are moving the buttons. That's the whole point. So the container now controls the positioning of the buttons. And now, for example, the container also can become hidden. So when we click on a button, we're going to make the container disappear. Oop, it's gone. So creating anti-GUI elements like this might be a good way to organize your GUI. You can cluster buttons and different GUI elements together. You can move them together. You can make them appear or disappear together. That's a nice way to organize things on your screen. And obviously, as I said at the beginning, you can also have multiple GUI objects that are separate from each other as well. So that was an introduction to the GUI system in Picotron. Now there's a whole bunch of other things that we haven't discussed. We haven't discussed drag and drop. We haven't discussed scroll bars and stuff like that. Let's tackle this on the next video about GUI. For now, I also want to hear from you guys. I want you to write in the comment section stuff that you want to know how to do in Picotron, the GUI stuff especially, and maybe I missed something or maybe I explained something wrong. Do let me know in the comment section for sure. Yes, yes, yes. And this is also the section where I will say a big thank you and a huge shout out to my Ko-fi supporters over at ko-fi.com/lazydevs. If you want to support this channel, if you want to support more tutorials, especially about Picotron in the future, then check out ko-fi.com/lazydevs. I know this channel has been a bit quiet in the last 2 months. I'm working on some new things. I'm figuring stuff out, and I discussed this also with my Ko-fi supporters. I have a special video I make for Ko-fi supporters, so that might be a good reason to check out the Ko-fi as well. This means there's more videos coming down the pike. I'm working on it. They just take some time. Stay patient. See you next time around, guys. Bye-bye.